We're going to work on writing some systems of equations today, which can be a little bit challenging, but I am confident that you can all handle it. So where I would start is defining your variables. If you write down, okay, X is going to stand for the number of cats and Y is going to stand for the number of dogs, it makes things easier to keep track of. Another good strategy is you can highlight different pieces of information that you're given and then see if you can write a couple of equations to go along with them. So it helps maybe to write them in words first instead of going straight to the variables, but those are all some strategies that you can use when you're trying to write a system of equations. Looking at this one, we are supposed to define our variables and write a system. We're not solving it. So on A, we're looking at two positive integers. One of them's bigger than the other. So I'm going to let X stand for my larger integer and Y stand for my smaller one. And now if I write some equations, I need to remember that integers are just whole numbers, both positive and negative, but specifically these two are going to be positive. One fact that I have is one of these numbers is 2/3 of the other, and the difference between them is 35. So let's start with that. One of the numbers is 2/3 of the other. So if you think about multiplying something times 2/3, it makes it smaller. So if I take my larger number times 2/3, it should equal my smaller number. So my larger number is X times 2/3 equals Y would be one equation that would work for that. If the difference between these two numbers is 35, if I'm getting a positive 35, then I must be doing the larger number minus the smaller number. Otherwise, it'd come out to be a negative value. So I'll have to have X minus Y equals 35. Now we have the ratio of boys to girls at a school dance. So the variables we're looking at are the number of boys and number of girls at this dance. So I'm going to call those X and Y. You could use other letters. I'm just in the habit of X and Y. One fact we know is the ratio of boys to girls at this dance is 5:3. So a ratio means if you divide those values, you get 5/3. So if I take the number of boys divided by the number of girls, I know that that should be equal to 5/3. Or you could think of it like for every 5 boys, there's 3 girls. So X divided by Y equals 5/3, or you could have equivalent forms of that equation too. Like if you think multiply both sides by 3 and then multiply both sides by y, you could have 3x equals 5y. Another piece of information we have is the number of boys and girls would have been equal if we had 3 more girls and 3 fewer boys. So again, there's a lot of different ways you could think about that piece of information. I'm going to think, well, if I added 3 more girls and took away 3 boys from the current number, then they'd be equal to each other. So y plus 3 equals x minus 3. You could also look at that though and think like, well, there's a difference of 6 between those, with there being 6 less girls than there is boys. Or you could think there's 6 more boys than there are girls. So just because you have a different equation doesn't mean it's wrong. So in this case, we've got a chemistry lab, and we have workstations set up for 2 students or 3 students each. So we're looking for the number of 2-person workstations. So our variables are going to be the number of 2-person workstations and the number of 3-person workstations in this chemistry lab. So if we look at our information that we are given, we're given the fact that the lab has 16 total workstations. So if I put my 2-person workstations and my 3-person workstations together, there's 16 total. So if I add up the values of x and y, because those stand for the number of each type of workstation, it should give me 16. So that would be one equation. If I look at my other fact, it says my lab can be used by 38 students at a time. So thinking about the number of students here is a little bit tricky. So I've got the number of students that are working at my 2-person stations and some other students that are working at my 3-person stations. And if I put all of those students together, I should get a total of 38 students. So to write an equation that matches this piece of information, I need to think about how I can represent the number of students at my 2-person and 3-person stations. Well, if each station that's 2-person holds 2 people, then if I take 2 times the number of 2-person stations, I'll get the total number of students there, and 3 times the number of 3-person stations should give me the total number of students at those. Sometimes thinking in terms of like actual fixed values helps. Well, I've got some stations that hold 2 people. Let's say I have 3 of those stations. That means 2 times 3, 6 total students. Let's say I've got 4 3-person stations. Well, then 3 times 4 gives me 12 total students at those. All right, back to the positive integers. So I've got that one positive integer is 16 more than a second. So again, I've got like a larger number and a smaller number. So x is going to stand for my larger number, and y is going to stand for my smaller number. So some facts that we are told is that we've got one positive integer is 18 more than my other. So if you think about, that means my larger number is 18 more than my smaller one. Multiple ways you could write an equation. You could go, okay, if I take my small one and I add 18 to it, it's going to equal my larger number. Or you could think, well, if I take my bigger one and subtract my smaller one, then it's going to give me 18. So I'm going to go with y plus 18 equals x, or you could go with x minus y equals 18, or there's other equivalent versions too even. Other fact that I have is the sum of twice the greater and 3 times the smaller is 86. So that's kind of a big piece of information there. We're talking about the sum of, so I'm going to be adding 2 things together. And what I'm adding is twice my greater number, so 2 times my bigger number x, and 3 times my smaller number, so 3 times y. And I'm doing the sum of those, so 2x plus 3y is supposed to equal 86. I've got Regina being offered 2 jobs with different annual salaries and like guaranteed raises every year. We're looking at after how many years her salaries would be equal. So things that are changing in this situation are the number of years that she's worked there, because that affects how many raises she's gotten, and the like salary that she's guaranteed to earn annually. So let's look at job number 1 and job number 2. So job number 1 offers her a total amount of money that comes from taking $30,000 as her starting pay, plus $2,000 times however many years it is that she's been working there. Job number 2 gives a total amount of money that's $25,000 plus increases of $3,000 per each year. So it's got a lower starting pay, but you get more money per year. So eventually that job's going to catch up and pass in terms of pay rate job number 1. The next thing we're going to do is look at several ways we could actually solve and figure out when those pays are going to be equal, which would let us figure out which job would be better.